In this video tutorial, I'm going to show you how to calculate the mass moment of inertia of an object in 3D Experience as released 2025X. Now, keep in mind that the uh, default CAD program that's buried inside of 3D Experience is the Catia program. However, it is not Catia V5 as far as the interface is concerned, and the difference is like night and day. However, I've prepared the same kind of tutorial, exactly the same tutorial for Catia V5 as you will see in a minute. If you're not interested in 3D Experience and you are interested in Catia V5's version, you can go to a different link. Now, first of all, uh, in the tools tab, you have something called measure item, and this is where you actually can calculate second moment of area, which is different from how it's done in Catia V5. Now, if you want to calculate the second moment of inertia or mass moment of inertia, you've got to go in there. Okay. Now, keep in mind that the Catia V5 version of this tutorial can be found in this link. All right, let's move on. First thing I'm going to do is to change my units so that the mass moment of inertia, which is right here, inertia product. So notice that I've gone to preferences and type here inertia, and this thing filtered it out. So it's inertia product. And this is actually what mass moment of inertia is. Unit kilogram meter squared. I selected meter squared. And inertia, I don't need it in this particular tutorial, but I just left it the way it is. So that's how you filter it out. And this, I'm going to change that the inertia, the bottom one is for, this is actually not correct. Let me correct this thing. So inertia is over here and mass moment of inertia is over there. Go back. All right. And let's move on. And the example that I'm going to do in this problem, and this is coming out of Miriam and Craig's book. The reason I picked this is because the calculations are done in the book, and this is what we're supposed to be getting. Notice that it says that the thicknesses can be ignored, and the density of this thing, mass per unit area, is 70 kilogram per meter squared. Okay. And so keep that in mind. Therefore, I'm going to create surfaces here. And on purpose, I'm going to create these surfaces in a very weird way. Okay. You'll see why. And what I'm going to get is from 3D Experience, I get this inertia matrix, and this is the calculation and calculation, exact calculation. And notice that they're very close. We'll get there. Okay, let's go ahead here. Because I want to create surfaces, I'll make my job easier. Go to the generative shape design. This is where I create the surfaces. So on that horizontal plane, XY plane, I will draw a line like that. And the length of that line is 125 millimeters. So let me put a dimension here, 125 millimeters. And I'll show you exactly what's going to happen here. Exit. And I'm going to extrude this up. So on the surface, I'm going to extrude this thing up by 100 millimeters. 100 millimeters. Okay. So what I've done is actually created for you this surface, and that surface is what you see over there, 125 by 100. Okay, good. Now I'm going to create the other piece. So again, on that plane, I will sketch. Let me orient myself as I like. And then I'm going to draw a line going from here to here, but I'll make sure that this line control, oh, what is that? Control this point, control that point. I'm going to make him coincident, right click coincidence. Okay, and this angle is going to be 90 degrees. So let me dimension this. Dimension between this and that, 90 degrees. All right, and this length is 75 based on the drawing. This is 75 millimeters. I'm sure you wonder why did I do this weird shape? Could I not have done this thing aligned with the X and Y axis? But you see why. I could have, but I want to do it like this. Okay, so exit, and then I'm going to extrude this thing by 150 millimeter. 150 millimeter. So what you see now, this piece is actually that piece. So the thing is that my global XYZ coordinate system is over here, but I want the XYZ to be Z along that line, Y along this line, and X perpendicular to it. So I go to Essential and create a coordinate system, axis system, and by default, it puts it at the global origin, but that's not where I want it to be. For origin, I select this point. Notice that Z is up, and X is like that. I want Y to be along this. So Z is up. See that? Z. Y is along that line, and X is this. Because you may not have a choice. I mean, this geometry may have been sent to you, and it may not be in the right place that you want it to be. So I create an axis system here. Okay, good. Now, the rest of it is you go to Tools, find that thing which says scroll until you get this measure inertia data. This pops up. So notice that you can do it with the surface or you can do it with volume. I'm going to surface, so I'm going to select the part body. The whole thing is going to be selected. The only thing is that, first of all, what is the material data that's used? Notice that the material data is, this is default properties of steel. I don't want it like that. I want the thing in Catia V5, actually you can specify the area density, but you can't do it in this version of Catia now, or either that, or I don't know how to do it. Let me be blunt with you. So let me do the following. First of all, that's fine, except that I'm going to change this thing to 70 kilogram per meter cube, and I'm going to define the thickness to be 1,000 millimeter. That means that 1,000 millimeter, remember, is 1 meter. Okay, so because the density is defined to be, actual density is 70 kilogram per meter cube, and the thickness is the dummy thickness is 1 meter. This will give you essentially 70 kilogram per meter squared. Okay, good. Now, so these are my material properties. Okay, the density specified so that it comes out to be 70 kilogram per meter squared. Don't forget to click on the recompute here. Don't forget to click on the recompute here. It'll give you the correct information. Now, the only thing is that I have a tab here that you may not have it when you try to do that. That's because I've already customized so that this tab shows up. First of all, I don't need this material properties. I'm going to close it. It's, notice that it's using the right values. I'm going to close that. But there is something called here customization. In the customization, I have already requested for inertia axis system, but you may not have that. If you don't have it, notice that this tab is not there. So click on customization, ask for it, and say OK. Now select that tab, and notice that it says, well, what is your axis system? Select the axis system, okay? And then I'm going to go from the tree or from the screen, select this. And notice what I've got here. These are exactly the numbers that I have down here. This thing is what I have actually copied and pasted there. These numbers. are exactly what you have there. Okay, good sign. This matches that. This matches that. Okay, this matches this. Two within the digits that I'm carrying here. And for example, that guy matches this, etc. So just keep in mind that these negatives are happening here because in Catia V5, the product of inertias are already have a negative in it. In the way it's defined in Miriam's book, this IXY is integral of x times y dm. Apparently, when they wrote the code in Katia, they're already saying that IXY is negative of integral of xy dm. All right, folks, good luck. Now, notice that this also could have been done. This also could have been done if you were to do a three-dimensional object, but then that means that you have to decide what this thickness is. It was unnecessary because of the way it's done in Miriam's book. Good luck.